Today we're talking about chapters 15, 16, and 17. So scope, more on types, and exceptions. The first one we'll talk about is scope. How do you control the access to your variables from different locations in your code? I'm going to just talk about how we define what a code block is, and then the difference between global, local, and block scope. Then we'll talk about variable shadowing, which we touched on before early on in the unit. And then we'll talk about variable hoisting. So a code block we define this as a section of code that's executed within the body of like a loop, a conditional, some sort of mechanism like that. It is not anything that is inside of a function. That's going to be different. So if you've just got some code out here outside of everything, and they're just individual lines of code, that's not a block. Here you have a function body, also not a block. But we have a loop, right? And then we also have a conditional. And in both of those cases, those are blocks. Okay, so that's just to clarify, when I'm talking about blocks, I'm referring to those types of things, not functions, and not just any regular lines of code that are outside of all of those. Okay, let's talk about the difference between these three scopes: global, local, and block. Global is where you have a variable that's declared at the very top level. It's outside functions, outside of code blocks. Local is when you have a variable declared inside a function, but outside blocks. And then block scope is anything that is inside block, which makes sense, right? Oh yeah, and with functions, parameters are also considered locally scoped, right? Because essentially every parameter is a variable that you just use inside that function. So here's an example. We've got a constant pi that we've created for ourselves. We have a get circumference function, has a couple of parameters here. We declare a variable here, diameter, and then we check, this condition here and declare another variable with, pi just being rounded to 2 decimal places, 3.14. And so we either return pi times diameter with our rounded pi, or we return pi times diameter with the original pi. So if I go to console log pi, the first one, the constant here, I'm going to get exactly what that is, because outside here, outside the function, no problem. This is in scope because that's where it was declared. If I try to console log something like diameter, which is local, or lowercase pi here, which is actually in a block scope in here, I don't have access to either of those. So I'm going to get a reference error. It's going to stop the program. So just to be clear, yeah. So this one's global. These are all local, radius, round, and diameter. And this one is block scope. Okay. So variable shadowing is this concept where you can have the same variable name in two different scopes. And it's very confusing for yourself and for others. So don't do it. It's the bottom line. There's just no reason to ever put yourself in the position of having to, get confused over, just name it something slightly different, right? Just avoid it. So if I have my word is trick, I also create a parameter called word that is scoped locally to this function, and I print it. And then I have this other function print that declares its own local word, and it says treat, and I print that from here. I can console log the original word and get trick, print word and get or, if I pass in or, and then if I just print the last function, because I set word as treat in that function, we get treat. And evidently the first time I wrote this example, it was Halloween. So there you go. Okay, so that's the idea. Just avoid using variable names more than once in different scopes. So variable hoisting is an interesting concept. It's this idea that you could actually declare your variable further down in the code than where you initialize it. And we know that JavaScript runs from top to bottom, with the exception of compiling functions to where they can be accessed from anywhere. As long as you're using let or const, this is not possible. But it is possible if you are using the keyword there, which is an old way to do JavaScript. You're going to see it out there because for many, many, many years, var is what was used. Or if you just leave it out altogether, you may have run up against this already, where you initialized the variable without actually putting let or const in front of it, and then you had access to it everywhere, and you're wondering why is that, right? Because JavaScript just automatically makes it global when that happens, but it's not done in modern practice. You really, because the emphasis is you just need to control your scope. You need to have very, very tight control over it. So use let and const everywhere and make sure you declare your variables exactly where you need them to be. And then you won't have any confusion and any issues. So with these examples, I could have some sort of condition somewhere, doesn't matter what it is. True or false, we set Polly is the value of bird and Spot is the value of dog. And these are in a block scope, right? And so, but I didn't use a keyword at all, which means they're automatically made global anyway. And you might think, hey, that's great. So I could console log bird and dog and no problem, I get the values. Here I could actually also just say var dog, and this would be the declaration for that variable here, but it's actually optional if you're leaving the keyword off altogether. Meanwhile, I try to do just cat equals Mr. Whiskers, and then I try to do let cat after the fact. That is going to give me a reference error because declaring it with let below where I actually initialize it is going to mean, it can't find it because it only knows about it with let if, anywhere after this point. So again, the preference is to actually control your scope and use let or const always. Let's do some examples. We've got some data to work with here where I've got an array of objects. Every single object has a name, a description, and some catchphrases in an array. So we have Woody, Buzz Lightyear, Mr. Potato Head, and Rex. Oh, and also Bo Peep. We have five characters from Toy Story, the mini Toy Stories. Okay. So we are going to write a function that will describe these toys, and it's just going to go through this array and access the objects one at a time, and we'll have a template literal that's provided for us here for describing each one using all of its properties. So let's define the function first. I'm just going to set it up at, here we go, function, describe toys, and we'll just pass in some sort of an array, right, of these objects. So I can create a block with a for loop here. We'll just go through the whole array. And I'm going to break everything down to where I can access each of the properties of the object, whichever object I'm on. I'm going to give them names. So I'm going to say let name equal array at index I dot name, and let description equal array at index I dot description. There we go. And quote one, because each of them has exactly 2 quotes. So we'll go to array at index I dot catchphrases at index 0. And then I'll do the same thing for quote 2 at index 1, since these are arrays here. Okay. So if I try to console log name right here, no problem. And let's see, I'll just do it with the chapter 15/scope. Okay. Oh, I haven't called my function. It would help to call the function. So let's try this out. And actually, Yeah, we can go ahead and just finish the function. Let me just go ahead and put in the sentence that we're supposed to put in here, and I'll copy it from here. Okay, name is a toy description who says things like quote 1 and quote 2. All right. So I'll call the function describe toys, pass in the toys array from above, and now I'll run it. Okay. So on every single iteration of the loop, we see the name logged and then, the sentence. Woody is a toy cowboy who says things like, there's a snake in my boot and reach for the sky. Buzz Lightyear is a toy space ranger who says things like, this is an intergalactic emergency and to infinity and beyond. Okay, so we have all these characters and all of their little catchphrases. So no problem. I was able to console log name there without a problem. If I were to try to do it here above its declaration with let, we get a reference error. It immediately stops the code and says, cannot access name before initialization. So that's not going to work because we actually declared and initialized it here. So I'm going to comment that out and just, say we got a reference error here. Okay. So no problem. But what if we were to start messing around with the scopes of these other three, description, quote 1, and quote 2? Let's see what happens if we just take let off of this, which is going to make description automatically global. I can console log description. Now we have a loop. Does anybody have any idea what value I might get for description if I console log it after the loop is ended?
What was that? Shepherdess?
Yeah, because it's just going to remember the last value that it took the last time it looped around, right? So let's do that and we'll see it come out here. And there it is, shepherdess. Okay. So that made it possible for us to do this. Let's try something else here. I'm going to actually take let off of quote 1. And what we're going to do is declare it here, just like that. And say, okay, we are, trying to use it up here. It's being declared with let down here. So what's going to happen, right? If I try to print this now. And we get another reference error. It can't access quote 1 before initialization. So we have the same problem as we did here, where now because we did use let to try to declare it further down in the code, it won't allow this anymore. So of course, the better thing to do would be to go back up here and just do let here and keep it scoped to the loop and not even try to access it from out here at all. But I think we have proven the point. So I'm going to remove this, and now when we run it, because it basically made it global by default, this is perfectly fine, and I can run this, and it gives us her, her quote here at index 0, be who you are right now. So similarly, if I were to just remove the let from quote 2, and then down here use the old keyword var that was what used to just be the only thing for JavaScript before let was introduced. We could do that with quote 2 and log quote 2. And we get he's not lost, not anymore, which is her quote from index 1. It's her second quote. Okay, so that's variable hoisting. That's that idea that if it's global or if you declare it with var, you can actually use it anywhere without, worrying about what scope it is and that sort of thing. But again, I repeat, don't do either of these things. Don't leave it off and don't use var. Use let or const and just make sure that you declare it where it needs to be so that's in scope where you need to use it. Okay. Does anybody have any questions about any of that?
Not looking that way just yet.
Okay, yeah, it's pretty straightforward stuff. And I think, it might help clear up some things in case you had some unexpected behavior in cases where you did leave off let or const before. But yeah, the convention is for everyone just to use it and just put them where you need them to be. Okay, so let's talk about the next chapter, more on types. Talk about this difference between primitive types and object types. And then I'll also talk a little more about the values null and undefined, because we've sort of talked about them, but I'll make sure to cover it a little more formally. Okay, primitives are simple data types. So string, number, Boolean, null, and actually string is kind of a funny one because it also is an object. It's based on an object, but in terms of the actual string value, it gets treated like a primitive. And then undefined. So these are kind of the five major ones that you deal with are as primitives. And then you have object types. There are things like data structures, arrays, and objects, right? So we have a number of examples here. A string, a number, a Boolean. We have a place where we set a variable empty value and set it to null. And then this one just says let not initialized, and we haven't initialized it to anything, which means its value is undefined. So we have an array that has a mix of a bunch of things. And here's an object that has, and it has some primitive values in it, in its key value pairs, in these cases, these two, but the thing as a whole is an object. And so is an array. So that's kind of the difference. When we talk about primitive, we're talking about these. When we talk about object types, we're talking about things like this. Let's talk about null and undefined. So null means empty. It does not mean non-existent. You set something null when you want it to exist, and you just essentially are giving it a placeholder for the value, but you just haven't assigned the value yet. And it's very common to do that with values of properties and objects where you need the key to be there. You want it to already have the key. You're just not ready to tell, say what the value is yet. So here's a house, and we've got information. Let's say that there's a realtor that's got the system and it's got all the houses, and it's got information about the house, the year built, the number of bedrooms and bathrooms. And then for sale is set to false. Well, what if they put it on sale? Then they would need to set the sale price, but they need the sale price key to already be there. So they go ahead and just set it to null so that it's clear. It's not that the sale price is 0. It's that we haven't set it yet. So that's null. Undefined, on the other hand, means that something doesn't exist at all. JavaScript does not know how to tell what it is. It can't even tell what type it is, much less, what a value would be. So if we were to try to console log some values here, like year built and sale price, year built gives us 1929, sale price gives us null. But if we were to try to log something that isn't there, house.address, there is no address key, we're going to get undefined because it can't find it. All right, I'm going to do some examples. We have some primitives. We have let boy equal Andy, let age equal 6, has baby sister is true, favorite pizza place is null, and favorite ice cream has not been set at all. And I have a little function here to print the value and type of each one. So we can just, see what its value is and see what its type is. And it says call the function for each variable above. So maybe the fastest way to do that would be to say, I'm just going to call it vars and put all of these in an array, and then we can just loop over it. So age has baby sister, favorite pizza place, and favorite ice cream. Okay. So now we have all 5 of those values in an array, and I'm just going to use a higher order function here. I'm going to say, let's do for each of those and just pass it print value and type so that it can run this function for every single one, and then we should see the result. So we will node chapter 16, more on types. Okay, value Andy, type string, value 6, type number, value true, type Boolean, null is considered an object, interestingly enough. and undefined is undefined. So there you go. If you're ever curious about sometimes the types of things that are unusual values like null aren't always what you expect it to be. So yeah, null is, it says a null is object, however, it's treated like a primitive, which is interesting. Okay, so we have that. Now we could come down here and talk about working with data structures, right? So we have an array and we have an object. So I could call my function again, and this time I won't bother with an array. I'll just call it print value and type of toy names and print value and type of neighbor kid. And we're going to see those come up. Okay, value is Ham, Slinky Dog, and Wheezy. And it just kind of stringified the array. You can see that it's got comma separated elements there. And it just says type is object. And then we have the value, and this is interesting. You're going to run into this a lot when you do graded assignment 3. Object is the value, and the type is object. That's because when you try to stringify something like this, it doesn't really necessarily print it the way that you would expect it to. If I were to just print the object itself, like without putting this string and concatenating it, I would see the object, right? So I could do that. I could actually just console.log neighbor kid, and I will see the object in the console, no problem. But when I try to do it this way and concatenate it with another string, it tries to stringify it and it can't really do it. So all we get is object. So keep that in mind. Anytime you ever see that show up in your console, it's because it's been stringified for some reason. And you just need to check and see if you're like concatenating it, or sometimes it happens when it's just like too deep inside of an object. And so it'll give you like the main keys and values, but then the things that are like nested down in there, it's just going to give you object at that point. So you'll have to kind of play around with that and see how that works. So null and undefined, let's say we have a function, play game, and all it does is just log this sentence. Hey, this is fun. And we also have an object Pizza Planet, which is got several properties of its own: food, drink, does deliveries, and video games, which is null. And we want to add a play method here that points to play game. So we can do that and say, let's just set play game as the function that will be run when we access pizzaplanet.play. So we can, check things like video games, which, we've set to null. So let's just say, let's go to pizzaplanet.videogames and see how that comes out. And we get null. Okay, so it recognizes that it's null. And then let's try to print something that doesn't even exist. Console.log pizzaplanet.hours. There is no hours key, right? And so we get undefined because it just doesn't exist. And now if I call the play method, I need to do pizzaplanet.play. There we go. It says, hey, this is fun. And then it says undefined. Can anybody tell me what just happened? Let me go back to the code. I'll pull it down. My console's all the way up here at the top. There we go. Yeah, let's take a look again at what I just did. I console logged pizza.play and I called it. And we ended up with 2 lines here. Does anybody know why we have the second line that says undefined? Nope. Okay. Because we called the function and it did what it was supposed to do. It console logged, hey, this is fun. So we see that. We also did another console log here and said console log the return value of pizzaplanet.play. But notice there is no return value. Anytime you console log the result of a function that doesn't have a return value, you're going to see undefined. And so if that ever throws you off, if you're running a function and you're like, wait, why is it saying undefined? Just check, because maybe that function doesn't actually return anything. And so it doesn't make any sense to console log it. So what you would do instead is just call it, right? So I could just say, pizzaplanet.play. And now when I run it, oops, there we go. And now when I run it, I just see, hey, this is fun. And I don't see the undefined. So just some interesting, you're going to see undefined pop up in different ways. And sometimes it's because you're looking for something like this, where it's a key that doesn't exist. And other times it might be because you're trying to print a return value that doesn't exist from a function. Okay, does anybody have any questions about any of that?
Not looked at that way this time.
Okay. All right, let's take, I know it's early. This is a shorter lecture. Let's go ahead and take our break now, and then we'll come back and we will do chapter 17. Okay, we're back. Let's talk about exceptions. We're going to just talk briefly about the common error types that we have talked about in the past, and then look a little closely at the error object that JavaScript uses to hold all the information about an error. And then talk about raising exceptions. What does it mean? What does it mean to throw an error? And then the try catch finally blocks, and how you can use that to actually handle errors very carefully and intentionally. So some of the errors that you can have during execution. So keep in mind, this is after the program has already compiled, and it would catch things like syntax errors when you have, when it's compiling. But the actual exceptions are the errors that happen during execution. So the program runs, and then it catches these runtime errors. So some of the most common ones you see are reference error, type error, right? And it's helpful to remember that you do not get any messages from, it doesn't actually tell you anything if you have a logic error. Your code just doesn't do what you expect it to do. So those you have to kind of suss out yourself. But with anything that causes an exception that actually stops the program and halts everything and gives you an error message, you might see something like this, type error, and it tells you a little bit of a message, and it gives you the file name and the line and the column. And then it will sometimes give you additional information after that, depending on how deep it goes and how it had to trace it down. So let's talk about this object that is represented here with all this information. The error object is something that has, it is literally a JavaScript object. It's based on the error class, and it will have a name and a message. And it also has this entire stack trace. That's what you see when you have that whole thing that shows up like this. It's called a stack trace. And it includes the name, and it also includes the message. And you'll have access to all of these properties of that object. So you literally, if you called it error, you could do error.message and error.name and error.stack to get to things like that. So let's look at that. What if you wanted to create your own error object? You totally could. You could use the keyword new to create an instance of the error class. Or maybe you want to get more specific. You want to create a type error, create a reference error, create something. You can give the error a useful message, whatever you want. And you just pass that into the constructor of this. And I know I'm using class terms. We're going to talk about this stuff tomorrow. It's okay. And then you can selectively print whatever you want from that once it exists. So if I create an error called E, and I just create an error object and I give it my own message, I can log e.name to get that type, e.message to see the message that I passed in, And E will give me the full stack trace, and so will E dot stack. You can do that either way. But again, this keyword here, new, is important here because it's basically saying, I want to create an object that's based on this error class. So I want a new instance of the error class, and that's going to be my object. And then, of course, you can just be as specific or as generic as you want. An error is kind of the most generic of all of the error types. Everything else is based on just the error. There's that message. Okay. So what if you wanted to throw an error on purpose? If there's something about your code that it might be an error that it wouldn't normally catch, but you would like it to stop the program and get somebody's attention who's in, and it probably would be like somebody who's another developer that's using your code. You can do that. So you can raise an exception wherever you want in your code, and you just use this keyword throw. And then you use that keyword new again to create an instance of the error class and throw exactly what you want. So you want to make sure your custom message is helpful, that it actually means something so that they understand what went wrong. So let's say we're working with this gravitational acceleration, and this time we're going to do feet per second instead of meters per second. So we have 32.17. And we're calculating the time to ground, and I'm not even sure this is right, but okay, so we're going to first check and say, is that actually a number? Because we can't do this calculation and get the result we're looking for unless it's actually a number. JavaScript isn't really going to it's not going to be a problem to try to calculate with something like that. It just would return not a number. But let's say we want to actually stop this and get somebody's attention and say, hey, you're not using this function correctly in your code, and you're producing not a number. So you need to go fix it and make sure that that value you're passing in is actually a real number, or else the application is going to break. So you could do that with throw and new, both of those keywords together, and then give it the error you want. And you can say it's a type error, and you can say height must be a number. So you're making it very specific. In this case, we have a custom message that has to do with the height for this function. It's a kind of a one-time thing, but this is how you would do it. And that way it would make sure that if someone used this function in their code, that isn't going to come out the way that they need it to come out, you can get their attention. So you would run it, console log, time to ground, and pass in the string 30, and it'll give you a type error. Height must be a number. All right, let's do a little bit of coding here and kind of see how this comes out. So we have a function get prize, and it has two parameters, kid and prize. And it prints something and says, somewhere nearby, you could swear you hear several tiny voices say, it's the claw, you have been chosen. And so then you can actually print the sentence, congrats, kid, whatever the kid's name is, you got the prize toy, whatever the prize is. And, kid uses the claw, gets the toy. So no problem. We can have Andy try for a three-eyed alien, right? So I could say get prize and pass in Andy, and three-eyed alien is the toy that he's going to try for. So I will node chapter 17. Oops. What just happened? There we go. All right, got the whole thing. Okay, and it says, somewhere nearby, you could swear you hear several tiny voices say, it's the claw, you have been chosen. Congrats, Andy, you got the three-eyed alien toy. No problem. However, we would like to have an exception. We do not want Sid getting any toys out of this thing. So we're going to try to circumvent and make it where he's not successful. And so we're going to throw an error in that case. So I'm going to say if kid equals Sid, and prize equals Buzz Lightyear, because he really wants the Buzz Lightyear, but Buzz does not really want to be tortured by him in his backyard. And so we're going to throw a new error, and I'm going to say, hey, that, and then I'll use a placeholder to put the prize in, isn't supposed to be in there. Okay, phew, crisis averted. All right, so let's have him try it. Get prize, Sid, and Buzz Lightyear. Okay, and we see our error thrown. It says, hey, that Buzz Lightyear isn't supposed to be in there. Okay, so we threw our very own error just like that. And it kept the function from continuing, and we never got to this line of code, which is exactly what we wanted. All right, I know that was a silly example, but I hope that drives the point home. Anywhere you want, you can throw an exception. All right, let's talk about try, catch, and finally. So the idea here is that you can prevent your code from failing by anticipating a potential error that might get thrown and then catching it so that your application doesn't actually stop. It'll continue on because you have a way to handle it. This is called handling your errors. So the try block will allow you to isolate the block of code that you think could potentially make your program break under certain conditions. And so you isolate that in try, it will run it. And then catch will follow, which follows that kind of they work together like this, right? You can see they're kind of all together. Catch will let you say what happens if an error does get thrown when you're executing the code in the try block. If that happens, we can capture the error object right here. You can call it error, you can call it E, you can call it whatever you want. It's actually very common for people just to use E. So you can capture it here and then do something with that and decide what you want to do in the case that the error is caught. But the important thing is, because we caught it, unless we actively want to stop the program, it's not going to stop the program. But you can still say what you want done here. And maybe you just want to print the message and move on or something. And then the finally block is optional. It really just ensures that you have certain code that's going to run next, no matter what. And you might have wondered, like I did at one time, why would you even bother with that? Like, if you have code, just put it below the try catch, right? But the thing is, when you're working with a large code base and a lot of code, things get moved around and get separated. And so really, the main thing here would be if you want code that's always going to be the very next thing that executes, and you can ensure that it's not going to get separated from this and other code get put in between, or it doesn't get removed, put it in a finally block. And that way you can be sure that the sequence will follow exactly this. Okay. So again, try is where you want to put the code that may cause an error. Catch is what happens if it does throw an error, you can do something at that point. And you have access to the error object, which we've just, seen how that's made up. And then finally is the code that will always execute. Okay, I have an example for this as well. We can take a look at this function here, execute recon plan Charlie, which takes in a string, an action. And then it has an object here called actions that has multiple keys for different actions that are possible with the string of what the guy should say, depending on what the action is. So we're going to see that we take that action, we make it lowercase so we don't have to worry about case sensitivity. And then we just log whatever string is stored for that particular action in actions. So we're just going to, make use of that using this variable with the bracket notation there. And then the last thing we'll do is just print this final little printout, recon plan Charlie. Okay, so let's try calling this function and passing in different actions and just see what happens. Okay, I'll run execute recon plan Charlie and pass in mobilize. And then we will run the program. And it says, all right, men, listen up. We've got a code red. And then recon plan Charlie. So our function's working just fine for something like this. We can run it a couple more times with other things like recon, and maybe here we run it with warn, and it should work every time, right? Yeah, we get time to scope out the birthday presents, and red alert, Andy is coming upstairs. Okay, what happens if we try to run it with a string that's not a key? Let's try run. And it says undefined, and then it just says recon plan Charlie. Well, that's not really something we ever want to happen. So we need to get the attention of whoever's using this function and maybe have some way to handle that, right? So the first thing we could do there is we can come up here and put everything into a try block. And I'm actually just going to set this up where you can see the try, catch, and finally all together. So try, and then open curly braces, and then catch and capture the error there, and open curly braces, and then finally, and open curly braces. Okay. So we want to put the code that we're attempting in the try block. So that's going to be these lines right here. I'm just going to move these up. And then here, this is the part that we want to happen finally. So I will put that in the last part. Okay. Now, so far, we haven't seen any actual errors thrown. Let's say that just for the case of there not being an action in the actions thing that's valid, so that key doesn't exist, we just need to check for that. So, and then maybe we create our own error for that with our special message, rather than letting, like tripping an error that actually stop the program. Although it won't as long as we have it in the try block, right? That's the whole point of this. But let's give this a try. So if I say if, and we can use actions.hasOwnProperty and pass in the action, and that will check to see if the key exists in the object. And then we could say, only if we can actually find the key do we want to print whatever that is. Another way to do this besides hasOwnProperty, we could also say if, and then the condition would be action in actions. You can use in as a keyword here to say if this property is in this object, and it will look and see and resolve to true or false. So it's the exact same thing that actions.hasOwnProperty with action is doing here. Either way. So we'll do that. We'll just make sure it only is going to print it if it actually is there. So if we run this again now, all we see is the stuff that's coming out of the finally block here, right? Well, maybe we actually do want something to be there, and we could create our own error and actually print something else instead. So I'm going to have an else for this condition so that we could do something else. And why don't we create our own error? Say let custom error equal new error. And we're creating an object of the error class, and I'll just log it with the name and say action is not a valid action for the army men. Okay. And I have two choices here. I could either throw the error and then catch it down here and let it print the message. Or I could have a custom message here. Let's do it the first way, throw custom error. And we'll watch it we're gonna watch it allow it to go through. So it looks just like it did before, right? We threw the error, but because of the try block and the catch block, it didn't stop our code, it just continued. If we want to actually see that error show up, then we would need to either print it here instead of throwing it, or we need to print it here. So I could say, let's console log e.message and just print the message. Let's run it again. Okay, run is not a valid action for the army men. Okay, so instead of seeing the sentence, one of the sentences that we are expecting to see, because that's not a valid action, we get our error message instead. Otherwise, it looks pretty similar, right? So that's one way to handle this. We may go back and change this a little bit in a second. Let's try one more thing. I want to try calling the function incorrectly, where we don't even pass in a string at all. Let's just say someone's using our code elsewhere in the application, and they just don't even have a string that they pass in. No argument at all. I can do that. And we get cannot read properties of undefined reading to lowercase. So that's kind of a funny sentence, but it is the message for a legitimate error. And I'm thinking, well, if something like this happens, I think I actually do want them to see the full stack trace. So instead of the message, I want the stack trace. Now, I'm not really interested in that for here. So let me say that for the type error that was thrown, because this is a type error that we just saw down in the terminal, I'm going to let it just do the whole stack trace. But for this one, instead of throwing the custom error, let's just print our own message. So I might have like console.log and do like a little series of asterisks here to kind of line out my stuff. And then I'll just print the name of the error and the message. So I'll say custom error.name, custom error.message. And then one more line here just for good measure. But I'll take that off. Okay. So let's try this. Oops, there we go. Okay, so we see run is not a valid action for the armyman, and then wrapped up in these asterisk lines now. So we got this special message here as part of the one where we actually used run, and then here we're just letting it give us the full stack for the type error where it says we can't read the properties of the undefined. You're trying to read to lowercase on a string that isn't even there because action wasn't passed in. So that really does trip an error. However, notice that we still have our finally block here. The code did continue. And if we really wanted to drive that point home, we could come down here and console log, if you're seeing this, you've handled your errors without crashing your program. Just to really prove that the code has moved on and it did not crash the program. So that's the beauty of a try, catch, finally, is that you can handle your errors exactly how you want to. You either, you can create a custom error or and print your own message, or you can let it print the message when it catches the error if you throw it. Lots of different ways to do this. And so hopefully that gives you a little bit of a picture of some of the different ways that you could use this to your advantage to make sure that the errors are not, swept under the carpet, but they're dealt with, right? Okay, who has questions?
Yeah, what's up?
The custom error is custom error object.
Is custom error an object?
Yes. Yeah, we created an object of the error class that has, a name, it has a message, it has a stack, it's got a bunch of stuff.
Yeah. You said you created an error object but didn't throw it. I assume you mean like didn't throw it intentionally with the throw. Okay, yeah.
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 Yeah, I decided instead of throwing it, and we could have thrown it and then just let it, so if I could do that, I could do that right here. So let's say we're in this else block, I create it, and maybe instead of printing my own error message here, I decide just to throw it and let it print it here where it catches it. No problem, we can do that. Throw custom error. And then we have the stack trace for both of them now because it got caught by the catch block.
Any more questions? We good?
Yeah, those Those are good questions. You know, there's a lot of stuff going on here, and I was trying to show you different ways that you can handle your errors. Sometimes you want to throw it and let it catch it and print the stack trace, and other times you might just want to print your own message and forego that. And we had two different things that were happening. We had the case where the key didn't exist, and then we had the case where the function just wasn't even called correctly to, at all. So it created two different types of errors. So yeah. But this is the kind of thing I've used this a lot. I would say the most I've used this kind of thing is when I'm doing error handling for like API calls or things like that, where I'm fetching data and I need to be able to put it on the web page, but if the data doesn't come back the way I expected it to, or there's some sort of server error, I have to handle all of those possibilities so that the website doesn't break if something goes wrong. And so I've used a lot of this sort of thing to handle like all those different types of errors. So it can be really useful. Let's come up over here. Okay. Yeah, I have some practice on handling exceptions. If you'd like to dig into this a little bit more, I've got an exercise for that on my website that is on Replit. I have this graded assignment prep tutorial called Backpacks, and it is also on Replit. I think I mentioned this last time, but it is running Jasmine instead of Jest, but Jest was built on Jasmine. The syntax is almost identical. You'll just see things like it instead of test for the specifications. There might be a couple of matchers that are slightly different, but the value of this is the problem solving aspect, how to build an object with a bunch of, and arrays of objects, and thinking through how you're going to test all those little bits and pieces. So I still recommend you take the time to do this. This is the one that most people really appreciate having to get them through their graded assignment. And it'll help you think through a lot of things that when you go to approach Mars rover, you'll already kind of have a certain mindset for how to approach it.